In this part of the tutorial, we will learn how to create a Microscope.JSON file from scratch, and specifically, we will create a Microscope.JSON file describing a Tier 1 microscope that is only used for qualitative or basic quantitative experiments. For this purpose, we are going to enter the information that is listed on Protocols.io under Step 3.2. Alternatively, if you want, you can also take this opportunity to start entering information about one of your favorite microscopes. So, once we are in the main window of the app, we can click on Manage Instruments. We can click on Tier 1. We can click on Create Inverted from Scratch, and then we can click on Continue.
After doing that, we are going to find ourselves on an empty canvas, and the first thing to do is to enter general information about this microscope. To do that, we can click on Edit Microscope, and under this tab, we can enter general information about this instrument. In this field, we are going to enter the name we use in the lab for the instrument, and in this other tab, we might also want to enter a custom name for the microscope stand on which this instrument is built. Sometimes this is a little bit redundant, but other times it is useful to have a custom name for both the instrument as a whole and the microscope stand itself. More importantly, in this tab, we will enter the manufacturer and the model for the microscope stand, which in this case is Zeiss and Axio Observer. Because right now I don't know the catalog number, I'm going to enter not available here. Finally, I know this is a compound microscope, and I also know that it is used as is. After this, I am going to click on Confirm, and now this part will contain all the information that I need for Tier 1. So I can save my work and create my first Microscope.JSON file. Here I want to take the opportunity to show you that if we click on Home and click on Load from the local home folder, we will find the file we just created in this list under the Zeiss manufacturer. So as long as the work is saved, a file can be loaded multiple times to continue the documentation work. There are different ways of proceeding, but what I like to do is to start by adding all the different hardware components that I want to document. So in this case, I will add a laser, I will add an objective, I will also open the fluorescent light path menu, and I will add a filter cube and the filters that belong to the filter set that is housed in this filter cube, as well as a dichroic. Finally, I will also add an EM-CCD camera, and then to be safe, I'm going to save my work again. At this point, I'm ready to start entering information about each of the hardware components I have added. So I can click on the objective icon, and again, notice that there are three tabs: General Information, Manufacturer Specification, and then a tab where I can record specific information about the objective. In the General Information tab, we can enter a custom name, that is the name by which the specific objective is referred to in the lab. So for example, this objective could be called Scratch 63X to distinguish it from other 63X objectives that are used on other instruments. After that, we can take a look on this website here and enter other information about this objective. The first thing we can enter is obviously the manufacturer, then we can enter the model name, and then the catalog number. Then down here we have other information we can enter that refers to the specific characteristics of this objective. A Tier 1 we only need the magnification, the numerical aperture, the correction, the immersion type, whether or not this objective is infinity corrected, whether or not it has contrast modulation, and whether or not it can be used for DIC. When we have entered all of these values, we can click on Confirm because we have all the information that is needed for Tier 1. One thing I want to make sure you notice is that when all information about a hardware component have been entered, this dot turns green, indicating that this objective is being validated at Tier 1. Before we go any further, we can now click on Save. The next thing I'm going to show you is how to use Micrometa app to record the information about a filter set, which is composed of an excitation filter, a dichroic, and an emission filter. To be able to see this better, we can enter Command+ and zoom in a couple of times and then center the canvas until we have a good view of this section of the instrument. So what we have here is a filter cube that houses a filter set, which itself is composed of an excitation filter, a dichroic, and an emission filter. We also know that the components of this filter set are dual band filters, including the dichroic, which is also dual band with a band pass and a long pass transmittance range. So we can either first describe the filter set and then the individual filters, or vice versa. What I prefer to do is start by describing individual filters. So let's do that. Because I know that this filter set is going to be housed in Cube 1, this excitation filter can be called Filter Cube 1 Excitation. After that, we can go to this next tab and enter additional information about this dual band exciter that we can find on this website. First, we can enter the manufacturer name, the model name, the part number. Then, in this other tab, we can enter that this is a multipass filter, it is hard-coded, it is located in infinity space. In order to find more fields that need to be filled in, one trick is to click on Confirm. When we do that, the app will show which fields remain to be filled by highlighting them in red. One other important aspect is that by default, filters are created with a single transmittance range band. So what we can do is start by entering the information about the first band, like so. Because we know that the first band for this filter is 482.22, we can enter 482 here and 22 here. After that, we can click on Confirm and exit the data entry window. However, because we know that we need to enter an additional transmittance range, when we click on the icon, we can again enter the data entry window, add an additional transmittance range, and enter the required information. At this point, we can again click on Confirm and save our work. At this stage, we can now enter the information for Filter Cube 1, which houses this filter set from Semrock. Under the Manufacturer Specs tab, we can enter that the manufacturer for the filter cube is Nikon, while the manufacturer for the filter set is Semrock. Then we can enter the model and the catalog number for the filter set. And finally, we can associate with this filter set the excitation filter we have created before by selecting it from this menu. In the same way, when we enter information about other components of this filter set, we can also associate each of them with the same filter set in these different tabs. Because of lack of time, I'm not going through all the different hardware components, but I hope that this is clear enough. In addition, if you have more questions, you can contact me and I'll do my best to help you with your documentation tasks. But before I close this part of the tutorial, I want to show you another important functionality of Micrometa app. So let's say that the first time you recorded the information about a given microscope, you were performing only some basic qualitative experiments. However, things have worked out and now you want to perform some more advanced experiments using the same microscope. What Micrometa app allows you to do is to open the same Microscope.JSON file at a higher tier level. In this case, we can choose Tier 2. Once an existing Microscope.JSON file is open at a higher validation tier, it is possible to either leave the validation level as it was originally or increase it. When we increase the validation level, we can notice that the information that we had entered for a given component at Tier 1 might not necessarily be sufficient to ensure validation at Tier 2. In a case like this, what I like to do is set the validation level at Tier 1, but then start entering more information in a gradual manner. So, for example, regarding this objective, I can look at the web page containing the objective specification and I can find more information that I can enter. For example, an additional piece of information that is available is working distance. Furthermore, I can enter information about the presence of a correction color, of an iris, and then click on Confirm. So here I want to point out that after adding more information, this objective is now validated also at Tier 2, as shown by this green dot. So the same process can be repeated with other components so that missing information can be added to bring the validation level to Tier 2 or even higher levels in case it is needed for other types of experiments. So I recommend that you adopt this trick to get started slow with minimal information and then proceed by gradually adding more information as they become available or if they are needed. Thank you for listening so far and please join us for our next video.